Greetings, globeheads and flathearts. You know, one of the favorite arguments that flat earthers like to make is that water seeks and maintains its own level. If you've ever watched a video by any of the big name flat earthers who have lots of subscribers, you've probably heard this as one of their leading arguments. And here's the thing about this particular argument: water seeks and maintains its own level is absolutely true. So, NASA fanboy, are you saying the Earth is flat? Well, not quite. You see, if you notice what these guys do is they will point out to you that water seeks and maintains its own level, and then with ever so clever sleight of hand, they'll try to slip that word level right out of there and replace it with the word flat as if they're synonymous, and they're not. Now, I know that some flat earther is going to go and get me some dictionary and cherry pick one of the definitions and show me where level means flat. I know this is going to happen, but like any other word in the English language, when words have multiple definitions, you have to take context into account. And in this particular context, level and flat mean two different things. Flat means there's no curve. Level means that we are talking about perpendicular to the pole of gravity. Or another way to say it is traveling equidistant to the center of gravity. So if I'm going to travel around the globe and stay equidistant to the center of gravity, or the center of that globe, I am going to travel in a curve. If I'm going to stay level, I'm going to have to curve with the surface of the Earth. But the reason why I want to talk about this particular claim is when you say water seeks and maintains its own level, it almost sounds as if you're pretending that water is special. It's not. Any any fluid will seek and maintain its own level. And so this claim is contrary. It directly contradicts a claim that flat earthers make. And this is the claim that if we didn't have a dome, our atmosphere would be pulled out into space by the vacuum of space. Our atmosphere is made up of fluids, and those fluids will seek and maintain their own level just like water will. Now, there's different levels. If you've ever had an old salad dressing bottle from back in the day when they used to make salad dressing out of basically vinegar and oil, you shake it up to mix it up to put it on your salad, but if you let it sit, pretty quickly the vinegar starts falling to the bottom of this bottle and pushing the oil to the top. This is because the oil is lighter than the vinegar. And we see this happen on our Earth. The water falls below the air, the gases that we have in our air. If there's some oil there, that oil will float on the top of the water. On top of that, we'll find the air gases, our nitrogen and our oxygen and all that. If you've ever played with a kid's balloon, you know that helium will find its level somewhere above that. You notice helium has mass. You'll notice that flat earthers like to pretend that it's like weightless, or it somehow defies gravity, or that it proves gravity doesn't exist. But helium is absolutely being pulled toward the Earth. It's just that the nitrogen and oxygen and the other elements in our air are heavier, and they fall under it and push it to the top. But why would anybody believe that our atmosphere should be pulled off into the vacuum of space? Perhaps it's because they don't understand how vacuum works. If you see a vacuum on Earth, if I had a container with a vacuum and I got a crack in the container, sure, air would rush into that vacuum from surrounding the container. But that's not how it's going to work at the edge of space. The reason the air is rushing into that vacuum on Earth is because there's air pressure pushing it there. about 14 pounds per square inch at sea level. But the air pressure diminishes as you go up. In fact, altimeters, I don't know if they still make them this way, but altimeters used to work by measuring the air pressure. It was so reliable, the drop in air pressure as you went up in altitude, that they would use that to measure their altitude. So why then would the air be trying to jump off into space any more than the water in your swimming pool is trying to jump off into the air? There's pressure at the bottom of your swimming pool. There's a lot of water pressure from the weight of the water above it. But just as that water seeks and maintains its own level at the top of the pool, air does the same thing in our atmosphere. Now, I've heard flat earthers say, but I haven't seen any water curve around no ball. Well, actually, you probably have. If you've ever been to the beach, if you've looked out on the ocean or looked out on the Great Lakes or anything like that, you've seen water curve over the ball. Maybe you didn't perceive it. Maybe you didn't recognize it. Maybe it wasn't enough for you to notice, but you've seen it. Because this is the way it works. We live on a big, huge, beautiful globe. And sea level is sea level all the way around it. There's a lot of fun to be had out there on the internet. There's a lot of cool things that you can find on YouTube. But there's a lot of folks out there trying to sell you snake oil. And don't buy their snake oil.